Let's take a look at MT3, LT3, problem 5. It says alternating current AC in an electrical current circuit can be described by complex numbers. In America, we use J. They're going to use I here. In any electrical current, Z. So your electrical current is Z. First thing we have to understand is what the variables stand for. The impedance in Z is the impedance in the circuit. Okay. It's related by the voltage V and the current I. So we have Z equals V over I. It says the standard electrical voltage in Europe is 220 volts. So in these problems, we know V is 220. I want to find the current if the impedance is 10 minus 5I. In other words, I want to find I if I know the impedance, which we're going to call Z, is 10 minus 5I. So now let's write that down. We know Z equals V over I. Or, since Z is 10 minus 5I, equals V, which is 220, we're going to divide that by I. I want to solve for I. Well, I don't like solving an equation with I, with the variable in the denominator. So what I'm going to do is I'm going to take the reciprocal of both sides. So I'm going to say 1 over 10 minus 5I equals I over 220. Well, then, to solve for I, we multiply both sides by 220. So in other words, I equals 220 over 10 minus 5I. Well, we know from our seminar, we can't leave an imaginary in the denominator. So when you divide by an imaginary, you actually multiply by the conjugate. So we're going to multiply numerator and denominator by 10 plus 5I. Now let's simplify that. Well, my numerator is going to be 2200 plus what's 220 times 5. Let's use a calculator here. Let's find it here. So if I take 220 times 5, I get 1100. So I get plus 1100I. Well, that's going to be 10 squared plus 5 squared, because we know it's a squared plus b squared when we're multiplying conjugates. Now it's just a question of simplifying. So we get 2200 plus 1100I divided by 100 plus 25, or 2200 plus 1100I divided by 125. Well, does 125 go into 2200? You get 17.6. Doesn't go in there exactly, but we're going to go 17.6. Plus, now let's take 1100 divided by 125. You get 8.8. And there's your answer.